Hello and welcome to this webinar on new release of MapleSim Web Handling Component Library, version 2024.1. I'm very happy to be here to once again talk about this library and the new features that we have added since we have last talked. So today I'm going to give a brief overview of MapleSim and Web Handling Library for those who are new to the simulation with our tools or the Web Handling Library. If you are actually new, I recommend taking a look at some of the other videos that we have on our YouTube channel, or have a look at our website for more information, as today's talk is mostly geared towards the current users. We also take a look at the evolution of the Web Handling Library and then get to the main part of today's talk about the new features. So MapleSim is a multi-domain system-level simulation environment that allows bringing different domains to a single simulation. As you can see on the screen, MapleSim includes a number of component libraries: electrical, mechanical, hydraulics, pneumatics, and of course, web handling. These components can be drag and drop and connect together to build complex dynamic systems. MapleSim connects to Maple, our flagship product for numeric and symbolic computation. And in the context of simulation, Maple provides an environment for scripting, programming, post-processing, and pre-processing. What completes this picture is our ability to generate code, and that code generation can take the form of C code, S-function, or FMU for integration of our models in the downstream applications. So let's start with the evolution of the library, which was released with version 1 in MapleSim 2021.2. In version 2, we added the laminating sub-library. This package allowed for merging of multiple webs into one and being able to simulate laminating processes. In version 3, we added two new span types. One was converting, the other one was sagging, or the one that would include the effect of gravity and had distributed mass. We also added more to our library of rollers. One was contact roller, would allow the roller to detach from the web, and the other one was a compound component for ease of modeling. In version 4, we added nonlinearity to the material. So this time the users can now provide the stress-strain curve and simulate models with nonlinear material behavior. We also added a new nib roller component with the ability to include slippage, and also more options for existing components. I have covered these 4 previous releases in 3 videos that you can find on our YouTube channel. I highly recommend, if you're new to web handling simulation with MapleSim, take a look at these videos and a lot of other videos on our YouTube channel, or also recommend to visit our website for more information. So let's look at the new features since those videos were published. So first, we talk about the features in MapleSim 2023.2 version 5 of the library, which included options for roller and wind and unwind drum. Let's take a look at these options. So components in Web Handling Library come with a lot of options. And in 2023.2 version 5, we added 3 more options to these components. We already had eccentricity as a fixed number. In this version, we added variable eccentricity, so the user can control when the eccentricity starts to affect the system. We added reset to wind and unwind drums, so that's simulation of cyclic productions can be made within the same model. And we also took a closer look at the winding process. And through our interactions with our customers, we decided to add a stepwise winding. So far, before this release, the winding process was smooth, as in the radius of the roll would smoothly or linearly with the velocity would increase. This time around, we looked at including an approximation of what happens when the web meets the previous layer on the roll, which creates a small step in the change in the radius, which would have effect in the rest of the web line through increase of the web speed, which then results in tension ripples. So let's start with looking at the variable eccentricity. Here I'm going to use one of the MapleSim examples. This model, once you have MapleSim, you can access it. This is an example of how eccentricity on one roller, if there is a slippage, can travel upstream, which is always undesirable. But here we are going to kind of modify this component here by activating the use input option, the new use input option, and instead of having a fixed value for the eccentricity, use a gradual increase. So we use the same maximum value as it is originally in this example, but increase it at 4 seconds into the simulation. So we're just going to run the simulation again, and our expectation is that nothing special will happen before 4 seconds. The system will have nominal behavior, but at 4 seconds, the eccentricity kicks in, and we'll see the same behavior as the previous model had. So this option is now added to the library, and hopefully you will find use cases when you are troubleshooting your model or trying to emulate defects in the system. The next option is winding reset. So this is also a new option that was added to the wind and unwind. Here I use an example and just activate the use reset option, and then attach a Boolean signal to trigger the reset. As you can see, the velocity is cyclic and the reset is cyclic. So the unwind continues to send material in, but this very simple model is there to show the cyclic production at the end of the line. So now that simulation is completed, we can take a look at the results. As I said, the speed is cyclic, the simple profile, and we can see the unwind drum radius is decreasing. However, the wind drum after a certain point resets and the simulation continues. The next item to talk about is a stepwise winding. As I mentioned previously, this time we're also going to use one of the examples that come with the library. Here we have again a wind unwind model, and first I'm going to activate the roll radius sensor for the wind drum, and instead of a smooth winding, I am using a stepwise winding. So the stepwise winding has an extra parameter of merge angle, as you can see on the screen, and that controls how smooth these steps are. And as you can see in the results, the effects are small in this case, and it's going to be dependent on the speed, tension, and the thickness of the web. However, you can imagine if there is a resonance in the system or a natural frequency within the operating range of speeds, then this small excitation could result in big changes in the system. So let's continue and look at the features that were added in 2024.1. We are going to start with a component that was added, switching nip roller. So the nip rollers in MapleSim, they all have fixed configuration that the users have to select before simulating, but in certain applications that we come across in battery production, for example, there are cases that the nib is moving and the web switches side. So in this simple example for demonstration, I'm actually using two webs just to highlight the contact arc, as we will see shortly, for demonstration purposes. And here I am moving the nib between two rollers, and you can see with the green highlighted contact arc, as the nib moves, the component automatically calculates and finds out which side it is in contact and incorporates the proper wrap angle on either roller. Moving on to the options that were added to the web properties. So we had the linear material, nonlinear material, and in 2024.1 we added 3 options to the web properties. One was to include the web mass in the machine direction. The other one was to start at equilibrium, and the last one to prevent negative tension. And I'll have examples to kind of explain what these options do. So let's start with prevent negative tension option. Here I have, again, very simple system for demonstration. I have a single idler and 2 spans. I'm specifying the upstream tensional velocity and the same velocity for downstream. We can see that we are accelerating to 1 meter per second over 2 seconds. And this acceleration causes an acceleration of the inertia of the idler, which in turn affects the tension in the upstream span. And since we are starting from 0 tension, as is in all models thus far in MapleSim, that acceleration results in a negative tension in the first span. This type of situations are usually something that one can ignore and continue the simulation once the steady state is achieved. But in certain cases that we want to look at it and we want to treat this negative tension as potential accumulation of material without really paying the price for sagging or any other feature, we can activate the prevent negative tension. As you can see, this time when the tension is negative, the material is assumed to accumulate in a span 1 at 0 tension. I'm going to now save this prevent negative tension simulation and see what happens if I wanted to do it a little bit more expensive simulation, but with inclusion of the sagging web, which does similar function in this case by as the web speed coming to the first span is larger than the speed leaving the first span. It will result in a slight sag in that temporarily. And you can see that we have similar behavior with our simple prevent negative tension approach, but it is a lot more efficient for larger models to use. The next option is a start at equilibrium option. As we saw in the previous example and other examples, when you simulate a model in the web handling library, all the spans are assumed to start from 0 tension. And we know that there is a time constant in the equations that come out from the equations that depends on the length of the span and the speed of the web. So here we see this accumulator model. One of the examples needs about maybe 15 seconds for the tension in all the span to reach the steady state before the simulation main function takes over and we have the accumulator going up and down. But sometimes this 15-second simulation is something that you want to avoid. This is not the part of the model that you are interested in, so you can activate the start and equilibrium, which then equates the strain in all the spans to the upstream value dictated by the unwind. And we can see that we can now focus on the main part of the simulation without needing to add some time cushion for the simulation to reach a steady state. The last of these three options is the web mask. This is usually, in most cases, a negligible effect, but for completeness, we added the conservation of momentum alongside the conservation of mass to the formulation of the spans. So with this option enabled, we can include the contribution of the accelerating mass to the tension behavior of all the spans. So as you can see, multiple options can be activated at the same time. So this one has the start at equilibrium and include mass activated at the same time. And we can see with this comparison simulation that there is indeed some effect on the tensions. But as I mentioned, for most material that we come across, this is very negligible. So other features, probably the biggest addition to 2024.1 was the inclusion of multi-web winding components. These include 2-web winding, 3-web winding, and 4-web winding. We already had the 1-web or the basic wind and unwind. Now for the winding drum, we have added 3 more components, 2 and 3 and 4 webs. Again, this was one of the components that we come across in manufacturing of batteries. And so this component would have use cases probably in other applications as well, but here we're going to talk about the 2-web and 4-web in form of examples. But before doing that, let's take a look at the options. So the options are pretty similar to, as you can see on the top row, for the wind drum, we had the alternate configuration, which we have almost all components have that. So the user has to decide whether the web goes over or under. You can activate the radial roll radius sensor, just like the 1-web wind drum. You can also activate a offset frame for these new components, and also include the fixed frame, which I featured in my previous video on new releases or new features. And this fixed frame will simplify some of the diagrams as well. Next on the list of options that these new components support is use CAD. So components like rollers and wind and unwind internally can calculate the mass and inertia of the core or the roller, but the user has the option to say they want to attach a multi-body object to represent the mass and inertia of the roll, or in here the core, and that could be also a CAD that you import into MapleSim. We do have the option to flip direction, just like all the other rollers. This was also highlighted in my previous new feature videos. Eccentricity can be added to these components. Variable eccentricity, just as we looked at it. The resets, again, as we just looked at it, are available on these components as well. The stepwise we reviewed earlier is available for these multi-web components too, but since these have multiple webs, they can have multiple steps. So you can activate an extra option and have multi-step. And the multi-step comes from the fact that, let's say in the 2-web case, web 1, when it reaches the previous layer, web 1 have a step, but when it reaches the previous second layer, have a step. The same goes for web 2. So in total, for every revolution, you can have 4 steps. For a 3-web winding, you can have 9 steps and for web winding, you will have 16 individual steps. So let's take a look at examples. So I have two examples here. One, a simple system to demonstrate the stepwise and multi-step winding in the 2-web case. I've intentionally selected thicker web, maybe not very realistic, but to kind of highlight what is happening to the system. You can see the two-top plot is the web velocity that is dictated by the wind drum. So as the radius of the roll jumps to the next layer over the merge angle that the user specified to how sharp or smooth these steps are going to be, the speed changes, and that change of speed can cause tension variation in the line. And just as we discussed, if these tension ripples can have the same frequency as some natural frequency in the system, then the effect will be a lot more emphasized. You can see the help pages for these components, and here we see a more complex model, still simplified for demonstration, but one that has 4 webs. And here we see one of them in the main view, and the 3 in subsystems. In some of my previous videos, I discussed how to organize models in subsystems so that your layout is a lot more manageable. This model also includes some motors and controllers. As we discussed, it's a multi-domain simulation environment. So here we see we have one unwind in the right-hand side of the picture, and the other 3 lines are not modeled from the unwind. They're just from one point in the web line, and they all come together at the 4-web winding component in the middle of the screen. So that concludes the feature review where we are so far in our development of the library. We do have a number of components that are in various stages of development, and some are even being tested by our users. So if you didn't find the component or the feature that you feel is important in the systems that you are modeling, I encourage you to contact us. We would be very happy to discuss our development plans and also try to accommodate your requirements in our development as well. So the library can include a lot of features, but as I said, we do have a lot of plans for the future releases of the tool. And I thank you very much for your attention to this talk.